So here we're going to put everything together. We're going to combine the product, the quotient, and the chain rule. And we're going to find the derivative. So in this problem here, I see I have 2x squared times, so that's a product rule, 3x plus 1 raised to the 16. So in here I'm going to have to use a chain rule. So I'm going to have to use a chain rule and a product rule because of those two things there. Okay? All right, so what is the biggest outside part? Well, let's read from left to right. Okay, so when we do that, I see I have the derivative of f of x. This is equal to f prime of x, which is what? It's the first, which is 2x squared, times the derivative of the second, so the derivative of the second, 3x plus 1, all to the 16th power here. Okay. And then plus the second, which is 3x plus 1 to the 16, times the derivative of the first. So the derivative of the first is 2x squared. Now, let's run through the math here. So I have the first here, which is 2x squared, times the derivative of the second. So how do I find the derivative of something raised to the 16 power? That's equal to 16 raised to, and then I have something raised to the 15 power. That something is 3x plus 1. But now that I've stripped away the outside, I've got to take care of the inside part here. And so I take the derivative of the inside, ddx, 3x plus 1. Always working through the chain rule all the way down. Okay, so that's the first times the derivative of second, plus the second, which is 3x plus 1 raised to the 16, times the derivative of the first. Well, the derivative of first, bring the 2 out front. 2 times 2 is 4, x to the 1. And if you wanted to, you could take the chain rule of the inside function. The inside function is just the x, right? But the derivative of x with respect to x is just 1, so that just cancels away. Okay? All right, so now I need to simplify here. This is 2x squared times 16. And then, so 2x squared times, that's actually going to be 32x squared times 3x plus 1 raised to the 15. The derivative of 3x is 3, and the derivative of 1 is 0. And then I have 4x times 3x plus 1 to the 16th power. Okay? Now, what's in common here? Looks like I've got 15 of these and 16 of those. Okay? I've also got a 4 here and a 32 here, so that 32 can break down to 8 times 4. And the 16 of these can break down to 3x plus 1 to the 15 times 3x plus 1 to the 1. Okay? So what can I factor out? I can factor out a 4 because there's a 4 in both of those. I can factor out an x because x squared is x times x, and I have an x here. Okay? And I can factor out 15 of these factors here. So 15 of those factors there. I'm going to factor those out. And so when I do that, what do I have left? Well, I have an x left over. Okay. I also have an 8 left over. And I also have a 3 here left over. So 8 and 3 make 24x. Now what do I have left over here? It looks like all I have left over is just this piece right here. We used the 4x and we used that 3x plus 1. So I have a 3x plus 1 factor left over from right here. Combine like terms. In my parentheses, I have 27x plus 1. So that is my final answer. Now that's a lot of algebra there. Say you get hung up on the algebra. Getting to this point right here is pretty good. That's going to get you lots of points there. Simplifying it will get you that full credit that I'm looking for. Okay? Now let's try another one. ddx x squared times 3 cosecant x. So how do we do this one? All right, once again, we've got a product holding those two functions together. Okay, but this one's derivative is going to be easy, but this derivative looks like we're going to have to apply the chain rule because it's 3 to something weird. Okay, so 3 to something, right, is 3 to something ln 3 times the derivative of the something, right? Chain rule. So I have a product rule and a chain rule going on. So whenever I do this, product rule says what? It says the first times the derivative of the second times the derivative of the second, 3 cosecant x, plus the second, 3 cosecant x, times the derivative of the first, ddx x squared. Okay? So I have x squared multiplied by this thing right here. Now the derivative of 3 to the something is 3 to the something ln 3 times the derivative of the something. Okay? So what is that going to be? That's 3 to the cosecant x times ln 3 times the derivative of cosecant x. Okay? So let me move this out of the way because that's only the first part. Now I need to do the second part. The second part is 3 cosecant x times derivative of x squared is 2x. Now, this next part here, simplifying this, the derivative of cosecant is actually equal to negative cosecant x cotangent x. Okay, so that negative is going to come out. I'm going to bring that negative out front. So I have a negative natural log of 3. I have cosecant x cotangent x. I also have a 3 cosecant x, and then I have an x squared. A lot of stuff going on there, right? All that stuff. Okay, plus 2x 3 cosecant to the x. Okay, now if I wanted to, I could factor this out. I could also factor, looks like I could factor one of the x's out too. So if you wanted to, you could factor an x times 3 to the cosecant x out. And if you did, it looks like you'd have negative x ln 3 cosecant x cotangent x plus 2. Okay? And then close my parentheses. All right, last one here. I'm going to take the derivative. Let's do a quotient rule for this one. So let's take 5x squared plus x divided by the sine of e to the x. Okay? So here it looks like I've got a quotient rule. I'm dividing two functions, so quotient rule. But not only do I have a quotient rule, I've got sine of something, so that's going to apply a chain rule there. So let's do it. So the derivative is low d high. So low, what's low? Sine e to the x. Low d high, the derivative of the top function. The top is x squared, 5x squared plus x. So that's 5x squared plus x. Low d high minus high d low okay, all over the square of what's below or low, so that's sine of e to the x times sine e to the x, or square it, sine squared of e to the x. If I simplify this, the derivative of 5 x squared is 10x. Derivative of x is 1 minus, and then I have parentheses 5x squared plus x times the derivative of sine of stuff. So the derivative of sine of squiggle is cosine squiggle times the derivative of the squiggle. Okay? So the derivative here is cosine e to the x. The squiggle is my e to the x here. Right, times the derivative of e to the x. Well, the derivative of e to the x is easy. It's e to the x divided by sine squared of e to the x. Okay, and not sure that there's anything that we can take out here. So that's going to be about as simplified as you can make it. So you can leave your answer just like that. Okay, hopefully these videos were helpful in showing you how these problems could be combined. You know, it can get really nasty really quick, as you saw here. You know, we did one where it was product rule and chain rule combined twice, and then our last one was a quotient rule and a chain rule. I mean, you could have a function where it was like, you know, you had a product rule in the numerator, like sine x times e to the x divided by, I don't know, maybe who knows, maybe it's like 3x plus 4 raised to the 5. Okay, and so you've got, not only do you have a quotient rule, you've got a product rule, but then you also have a chain rule here. Okay, so, you know, I don't know, maybe we should do this. So I just made that problem up. Maybe it might be good for us to work through. So low d high. So if I want to find f prime, the derivative quotient rule is the overall rule here. Okay, it's holding those functions together. So low d high, so that would be low 3x plus 4 to the 5th. D high times the derivative of the numerator, sine x e to the x, minus high d low, sine x e to the x. D low is ddx 3x plus 4 to the 5th, all over 3x plus 4 to the 5th squared. Okay, now I've got 3x plus 4 to the 5th times the derivative here. The derivative here is a product rule. The first times the derivative of the second. Derivative of the second is just e to the x. Plus the second, e to the x, times the derivative of the first. Derivative of the first is cosine x. Okay? And then minus sine x e to the x. And then my derivative here, I got to use a chain rule. Chain rule says the derivative of something raised to the 5th power is 5 times the something raised to the 4th power. And then the derivative of the something, the derivative of 3x plus 4 is just 3. Okay, all divided by, well, something that has a power to a power, I multiply the exponent, so that's 3x plus 4 raised to 5 times 2, which is 10. Okay, that's a big old mess, and one in which I don't really care to simplify. Okay, so I think you could cancel some stuff. Like you see here, there's 5 of those 3x plus 4 factors, and then there's 4 of them here, and then there's 10 here. So you could cancel 4 of those out of everything, right? And so you'd have sine x e to the x, which I guess you could factor an e to the x out. So you have a sine x plus cosine x, and you factored an e to the x out. And then you have one of those 3x plus 4s. And then over here, I take out all of those, but I have the 3 and the 5 make the 15. Sine x e to the x. Okay. So technically, I guess I could put another parentheses and factor that out, but I'm not going to worry about that. Don't want to get too complicated. And then this is 3x plus 4 raised to the 6, because I took 4 of those out because of this over here. Okay? So, but the main thing is that you're able to get to this part right here, and then simplifying it, that's just that extra 1 point or whatever it is. But that combines all of the different three derivative techniques that we've learned in this section. All right.